Welcome back. In this video, we're going to be talking about triangle congruence being used in the reverse direction, what we call CPCTC. Okay, ooh, what is that? So first of all, let's go through a little practice problem that we went together in class. This is also on Agile Mind, and we're going to review exactly what's going on here, right? So first off, we need to establish that these triangles are congruent for what we're about to do. This is a real world problem where someone is surveying the land, measuring areas on the land and such. They need to find the width of this lake, but the tools we use for surveying are a little wheel we push. We're not going to be walking along the bottom of a lake with an electronic wheel, right? So we're going to want to make this weird shape. That's what the surveyor tells us we want to make. And somehow it'll let us measure the width of the lake. Oh, what's going on there? So we're going to figure out exactly how that works. And the first thing we're going to figure out is the surveyor asks us, make sure the triangles are congruent. So we build the triangles and we're going to check to see they're congruent by their instructions. So I need to figure out, again, proving congruence, right? I'm going to use one of my four postulates here: side, angle, side, 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 angle, and angle, side. Right off the bat, I can eliminate side, side, side. If I knew the width of those sides that we haven't measured yet, right, I wouldn't be doing any of this. I don't know the width of the lake, so I'm not using that one. I'm not given two angles here, so I'm probably not using one of the ones that requires me finding two angles. I've been given two side correspondences, right? 30 to 30 and 40 to 40. I'm not given them with congruence markings, but remember, congruent sides are sides with the same side length. So if I'm told that they're the same side length, that's the same thing as saying they're congruent. Now, to find two more angles would be eliminating one of my pieces of information and finding a lot more. I could maybe do that, but I like to start with as much of the information I've been given as possible. So I'm going to start by pursuing side angle side. What that means is I want to find this angle in the middle is congruent to that angle in the middle, right? What can we use to find that? Try to remember from the last video or from the angle relationships we've used in the past. All right, so maybe you reviewed your notes, maybe you just reviewed your memory, right? But if you came back after pausing it to think about that for a second, maybe pause it now if you haven't. What we have here is a vertical angle relationship, right? When we have two triangles touching at the tips or the corners like that, the angles across from each other are vertical angles, and they are congruent by definition. So we have been able to prove here that we have a side, an angle, and a side that corresponds like so. That makes these triangles congruent. So pretty quick little problem there, right? But that's not the end, because our land surveyor wanted us to make these triangles with these measurements specifically so that we could find the side length of our lake. So how does these being congruent help us with that? Maybe pause the video and consider, can you see why would these triangles being congruent help us figure out how wide the lake is? All right, so hopefully you pause the video and you have an idea for why the width of the lake is given to us by knowing these triangles are congruent. Remember that the definition of a congruent triangle is very important. Every time we do an intermediary step, like to find the width of the lake, first we find the triangle's congruent. That means something about being congruent tells us something that we didn't already know, right? So being congruent tells us a useful piece of information that we didn't already know. That useful piece of information is probably going to be locked into the definition of a congruent triangle. If you remember, congruent triangles have 6 pairs of corresponding sides and angles. When we prove congruence, we might use less than 6. But once we've proven they're congruent, all 6 corresponding pairs are guaranteed to be congruent. The title of this video says CPCTC, and that is an acronym for what we're about to use. That corresponding parts of congruent triangles are congruent. That is what the definition of congruence says. Remember, reviewing the video for that, we have an if and only if definition, right? That means it works both ways. We can find the pairs to prove congruence, or we can prove congruence to find the other pairs we didn't use to prove it. I didn't have that this side was congruent to this side before. But once I've proven they're congruent using the side angle side relationship, I now know that the third sides are congruent to each other. That's how proving congruence helps, because it allows us to use CPCTC. All right? Corresponding parts of congruent triangles are congruent. Once I've shown the triangles are congruent to each other, I can show that their corresponding parts are congruent to each other. We already kind of knew this. It's just using it in a different direction intentionally, right? That once we've proven congruence, we can show correspondence. But we did this when we first talked about what corresponding meant, right? I gave you two congruent triangles, told you to find the corresponding angles and the corresponding sides, and we were capable of doing that. So I look forward to you applying this to solve some other problems. Okay? Good luck.